So what does it mean to square something? What does it mean to square something?
To square you
times it by itself. So if I am squaring 7 times the square root of x plus 6, I'm going to multiply it by itself. So for starters, I'm just going to take and write it out long ways like this. We have multiplied terms that look like this before. When you look at just one of those sets of parentheses, is there a plus or a minus that's not under the radical, that's not part of the radicand? No, then we treat it as a single term. These things are being multiplied together right here. So when I square this, I'm going to multiply the parts that are not underneath the radical with themselves. Yep, so that would give me 7 squared, which is 49. Do my radicals have the same index? Yes. Then I take these pieces and multiply them. So the square root of x plus 6 is getting multiplied by itself. I heard already that 7 squared would give me what? 49. And then I'm looking at this thing right here. How will that simplify the square root of x plus 6 squared? How will this part with the yellow box around it, how will that simplify? Yes. What is the index on this radical? The index is 2. And we're raising it to the power of 2. These two things match, and so they will cancel each other out. So I would just have x plus 6 left. So I have 49 and then x plus 6. There's one more thing that I see I can do with this. Distribute. I can distribute that 49 to both terms inside the parentheses. So I would have 49x plus what? $49x plus what? 294. All right. Thank you. For the second one, I'm squaring this, so I'm multiplying it by itself. So I'm going to write it out in expanded form first. I have the square root of x minus 5 and then plus 3 times the square root of x minus 5 plus 3. Are there any pluses or minuses that are not part of the radicand? Any pluses or minuses that aren't under the radical? Yes. Then I have to use double distribution. This is not considered a single term if there's a plus or a minus that's not under the radical. So first I'm going to distribute here. Square root of x minus 5 times another square root of x minus 5. So I'm multiplying it by itself. And then I distribute over here. So plus 3 times the square root of x minus 5. I'm going to distribute this 3 to both pieces. So plus 3 times the square root of x minus 5 plus 3 times itself, or 3 squared. What will happen to my first term? Use the distributive property. If there's a plus or a minus in between two terms, we have to use the distributive property. We have to double distribute. So if it is not part of the radicand, if there's a plus or a minus that's not part of the radicand, The whole big difference here between these two is that here, thank you, ma'am, the 7 is being multiplied to my radical, and down here, the radical is being added to the 3. So that's what changes my approach on these. What happens with this term right here? What power are we taking it to? Second power. What's the index on it? Index is 2. So what happens when my exponent and my index match? They cancel each other out. So this is going to cancel with this. So I'm going to have just x minus 5 left. What do we know about these two terms in the middle? They are the same. These are like terms. So we can combine them. How do I know if something is a like term when it has a radical? What am I looking for to know whether or not it's like terms? What things do they have to have in common? The index has to be the same. What else has to be the same in order for them to be like terms? The radicand, the part under the radical. Do these two radicals, what I've got the black bracket around, do those two radicals have the same index? Yes, it's an index of 2. What is the radicand on each one of them? X minus 5 and x minus 5. I'm looking at the second one down. So these are like terms. So I have 3 radical something plus 3 more of the same radical. How many do I have if I put the 3 and the 3 together? 6. So I have plus 6 radical x minus 5. How does this back here simplify? That is 9. So I got 9 from this. I put my like terms together. This right here gave me x minus 5. Have I combined all the like terms together at this point? What else could I still combine together? Not the 6. 6 is being multiplied to this guy. The negative 5 and what? And the 9. What happens when I combine those two together? I get 4. So x plus 6 radical x minus 5 plus 4. Or you could have written x plus 4 plus 6 radical x minus 5. Where you put the plus 4 doesn't really matter. It could go all the way at the beginning. You could have 4 plus x. We just need to combine those two like terms together in the end. All right. I want to show you guys how to use graphing software to solve problems like we were looking at yesterday, to solve radical equations. And then we're going to do a little bit more practice with solving radical equations algebraically. Yes, ma'am. So I'm going to be pulling some problems from the book to show you how to use graphing software to solve. I'm going to be pulling problems from page 345 and page 346 if you want to follow along with me. So I'm going to go to Desmos. So I've got Desmos pulled up. And the first problem that I am going to graph, 345 is the page that I'm on right now. I'm pulling this problem off of page 345. So this is the problem from example number 5. The way I use graphing software to help me solve a problem like this, I'm going to take everything on the left-hand side of the equal sign. I'm going to put it on this first line in Desmos with a y equals in front of it. Y equals 2, and then the cubed root of 3x minus 4 plus 10. So I'm going to graph just the left-hand side. And then I'm going to grab everything on the right-hand side, and I'm going to put it on its own line with a y equals. And I'm going to look for where these two things intersect each other. So I'm getting ready to type it in. It's going to take away what I've drawn on here when I type it in, but I wanted to show you guys what I'm doing first. And what I'm looking for is where they cross each other. All right, so right up here, I need y equals, looking at the left-hand side, I have 2, and then I need the cubed root of 3x minus 4, and then outside of my radical, I have plus 10. So there's the graph of just the left-hand side of the equation. The right-hand side of the equation just has a 9, so I'm going to put y equals 9. Do these two things cross each other? Yes. I'm going to click on the point where they're crossing each other, and the x part of that ordered pair would be my solution to this equation. So right here, I'm going to click where they're crossing. 1.292, the x part of the ordered pair, because I would be solving this equation for x. So the x part of the ordered pair would be my solution. I'm going to do another one. The next one that I'm going to show you is on page 346. It's the problem in example number 6. Example number 6 has the square root of x plus 6 minus 5 equals negative square root of 2x plus 1. In order to use my graphing software to help me solve this, I'm going to take everything on the left-hand side of the equal sign. I'm going to put it up here with a y equals it. Y equals square root of x plus 6 minus 5. What do I do with the other side? What do I do with all of this? Put it on the next line down with a y equals in front of it. Y equals negative square root of 2x plus 1. So I'm going to type it in separately, left-hand side, right-hand side. We're going to be looking for where they intersect each other. Okay, so underneath here, y equals square root of x plus 6, and then I have to move outside of my square root, minus 5. There's that graph. That's the graph of the left-hand side of my equation. Then I'm going to do the right-hand side of the equation. So I need another y equals negative square root of 2x. Move out from underneath my radical, plus 1. Do those two graphs intersect each other anywhere? Yes. When I click on where they're crossing each other, which part of the ordered pair tells me the answer? The x part. 4.018 would be my solution. Question. What if I'd had these two graphs? If I graphed the left side and I graphed the right side, and this is what I saw, what would my solution be? No solution. Why no solution? Because they're not touching each other at all. They're not ever crossing. I am not going to expect you guys to use graphing to solve on the test. However, in other classes, you will be expected to solve by graphing. And it's also a really good way to check your algebraic work. If you're not sure you did it right, photomath isn't working for you, you can put the left-hand side and the right-hand side into Desmos and check where they're crossing to see if you got the correct answer. All right. I want you guys to grab the single sheet of paper, not the stapled one, but the single sheet of paper. We're going to do some more practice with solving that we learned how to do yesterday, solving algebraically. We learned yesterday that there are 3 steps to solving a radical equation. The first step is to isolate the radical. First thing we do is isolate the radical. Then we will eliminate the radical. Does anybody remember how we will go about eliminating the radical? If it's a square root, we're going to square it. What about if it's a cubed root? Then we'll cube it. We will raise it to the power of the index. Whatever the index is, that's what we're going to choose as our exponent. After we have isolated our radical and we've eliminated our radical, then we will solve and check. So on the first one, step number 1 is to isolate my radical. Well, here's my radical. Is there anything else on the left-hand side of this equation? This is already isolated for me. So step 1 is already done. So then I move on to step 2, and I have to figure out how to eliminate my radical. We said we're going to raise it to the power of the index. What is the index here? Index is 2. So I'm going to raise this side to the power of 2. And if I do it to the left-hand side, I have to do it to the other side, do it to the right-hand side. So I have to raise both sides to the second power. What happens when I square something that has an index of 2? Cancels out. So the radical totally and completely disappears. I'm just going to have 4p plus 5 on the left-hand side. Radical is gone now. What will I have on the right-hand side? 49. Where would I go from here to finish solving? Subtract 5 from both sides. What is 49 minus 5? 44. So 4p equals 44. What do I do from here? Divide both sides by 4. And so that means p is what? P is 11. How do I know if that answer is valid or extraneous? We're going to plug it back in, so I'm going to check this. This is always the last thing you need to do on these problems is check them. We go all the way back to the original equation. So the square root of 4p plus 5 equals 7. What am I putting in the place of the p? We're going to put 11 in the place of p. And if it's a valid solution, then it will come out to be 7. I don't know yet what it comes out to be on the other side, so I'm putting a question mark over the equal sign. What can I do just on the left-hand side? I'm not going to move anything from one side to another. I'm going to stay right here. Yep, I can do 4 times 11. What is 4 times 11? So I have 44 plus 5 under my radical. What can I do with this now? I can add those. What is 44 plus 5? I get 49 underneath the radical. Can I simplify that anymore? What is the square root of 49? 7. So is this valid or extraneous? Valid. How do we know? Yes, on this other side, I had a 7 already, and those two things are equal. So this is a valid solution. Let's look at number 2. First thing I need to do, what is step number 1 again? Isolate the radical. Where's the radical? Left-hand side or right-hand side? Left-hand side. Is it all alone? Is it isolated? Nope. This right here is what I need to isolate. So who's got to go? How do I get rid of that 7? Subtract it from both sides. So I'm going to subtract 7 on both sides. I have the square root of 5g minus 1 equals 7. Have I isolated my radical now? Cool. Step 1 is done. I'm ready to move on to step 2. What is step 2? Eliminate the radical. How do I eliminate the radical? Take it to the power of the index. So what is my index? In this case, my index is 2 again. So I'm going to take this side to the power of 2, and if I do it to one side, have to do it to the other side. What happens over here? They cancel out. The squared and the radical will cancel each other out. So I have 5g minus 1 equals what? I heard 49. What do I do next? Add 1 to both sides. So I have 5g equals 50. Divide both sides by 5, so g is how much? G is 10. How am I going to determine whether that is a valid or an extraneous solution? Plug it back in, so let's check this. My original equation is 7 plus the square root of 5g minus 1 equals 14. What are we going to put in the place of the g? We're going to put 10 in the place of g. If it's a valid solution, I should get 14 over on the left. What's the first thing I'm allowed to do on the left-hand side? Multiply the 10 and the 5 together, yes. What is 10 times 5? So I have 50 minus 1 under my radical, and then I got that plus 7 out front. What else can I do to this side? I can subtract 1 from the 50 and get what? 49 under my radical. Square root of 49 is 7, so I have 7 plus 7, which gives me 14. So is it valid or is it extraneous? This is valid. The other side, I had 14 the whole time. Those two things are equal, so this is a valid solution. You guys ready to try one that has a different index? All right, let's look at example number 3. About halfway down the page. Can you guys see what the index is on this one? Yes, it's an index of 3. There's a teeny tiny little 3 right there. It's kind of hard to read. First thing we're supposed to do is isolate the radical. Is my radical isolated? Yes. It has already been isolated for me. So I have the cubed root of 6k minus 8 equals 4. Step 1 is done. Step 2 is eliminate the radical. How do I eliminate this radical? Cube it. We're not multiplying by 3, we're taking it to the third power. And if you do it to one side, you've got to do it to the other side. Why did we pick cubing this time? Index is 3. So what's going to happen over here on the left? Cancels out. The cubing and the cubed root cancel each other out. So I don't have a radical anymore. I have 6k minus 8 all by itself. Equals. Now I've got to cube the other side. 4 cubed. 4 times 4 times another 4. 64. What would I do next in my goal to solve for k? Add 8 to both sides. What is 64 plus 8? 72. So I have 6k equals 72. Divide both sides by 6. What is 72 divided by 6? So k equals 12. I'm going to skip the check on this one because I want to make sure that we get through all the examples before the bell rings to end us for class. So you would still then need to go on and check. What's different looking about number 4 than any of the problems that we've done? It has a fraction. Can you guys see what that fraction is? 1 over 3. When I have a rational exponent, I want to rewrite it as a radical. How do I know what my index is? The denominator. So here's my index. So that means it's going to be a cubed root. So 2, and then the cubed root of 3a plus 4, all to the power of whatever my numerator is. Minus 6 equals 0. If things are to the first power, I do not have to keep writing that exponent. So if my numerator is a 1, it's just going to be the cubed root of whatever was inside the parentheses. Because I wrote it wrong. That's how. All right. So now I know I'm looking at a radical equation. Step 1 is to do what? Isolate. This is the thing that I need to isolate. I see two things that I need to get rid of, the 2 out in front and then the -6. Which one do I get rid of first? The -6. How do I get rid of it? Add 6 to both sides. So I would have 2 and then the cubed root of 3a plus 4 equals 6. Still need to isolate this. I heard subtract 2. What's connecting the 2 to that cubed root? What operation is connecting those? It's multiplication. How do I undo or get rid of multiplication? We're going to divide. So I'm going to divide both sides by 2. So I have the cubed root of 3a plus 4 equals what? Equals 3. Have I successfully isolated that radical now? Yes. How do I eliminate the radical? We're going to raise it to an exponent. What exponent do I want to choose? 3. Why 3? That is my index. Whatever the index is, that is the exponent that I will choose to raise it to. And if you do it to one side, got to do it to the other side. What happens on the left? They cancel each other out. So I have 3a plus 4 equals what? 27. 3 times 3 times 3. What next? -4 on both sides. So 3a equals what? 23. What do I do to get a all alone now? Divide both sides by 3. If I do 23 divided by 3, will that come out to give me a whole number? Will it give me something pretty on my calculator, like 2.5? Then I'm going to leave it as the fraction, 23 over 3. I do not want to write this as a decimal because it's one of those decimals that runs off the screen on my calculator. If it does not run off the screen on the calculator, I'm fine with you writing it as a decimal, but if it runs off the screen, leave it as a fraction. If you were doing this for me on a test, what would you need to do after you get all the way to here? Then you would need to check it. I want to get through these last 2 problems before the bell rings, though. Can you guys see what the exponent is on number 4? No? All right, let me pull it up here and see if we can see it up here any better. On number 5. This guy right here. It's 1 over 4, yes. I know it's very hard to see on your paper. It did not print clearly. I'm not quite sure why it's so fuzzy. It didn't look that fuzzy on my computer screen when I went to hit print, so. How can I rewrite this? We're going to rewrite it as a radical. So what will this look like? The index is 4. So this is going to be a 4th root of 3b minus 5, all to the power of what? What's my numerator? All to the power of 1. Minus 2 equals 3. If I have something to the first power, do I have to keep writing that little 1 for the exponent? Nope. So this is the 4th root of 3b minus 5 minus 2 equals 3. What do I do? Add 2 on both sides. We want to isolate this. So I'm going to add 2 to both sides. So the fourth root of 3b minus 5 equals 5. What do I do after that, and why do I do it? Raise it up to the power of my index. So we're going to raise it to the power of 4. Here's my index. So we're going to raise it to the 4th power, but if I do it to one side, have to do it to the other side. On the left, my exponent of 4 and my 4th root cancel out. So I have 3b minus 5 equals, what do I get on the right-hand side? 625. I have 5 times 5 times 5 times 5. Where to from here? Add 5 to both sides. So this would give me 630. And then what? Divide both sides by 3. 630 divided by 3 gives me 210. Then you want to check. All right, one more that I want to look at. We are going to rewrite this as a radical. What is that little fraction exponent? It's really hard to read. 1 over 5. So 1 over 5, we're going to rewrite this as a radical. So I have the 5th root of 5k plus 7, all raised to the power of my numerator, plus 12 equals 14. So the 5th root of 5k plus 7 plus 12 equals 14. What do I do from here? Subtract 12 from both sides. We're going to isolate our radical by subtracting 12 from both sides. So I have the 5th root of 5k plus 7 equals 2. Raise it to the power of the index, so I'm raising it to what power? Raise it to the 5th power. Yes. And if you do it to one side, we got to do it to the other side, so I raise both of these sides to the 5th power. So the 5th power and the 5th root will cancel out on the left-hand side. 5k plus 7 equals 32. We are almost there, guys. What do I do from here? Subtract 7 from both sides. What is 32 minus 7? So 5k equals 25. Divide both sides by 5. K equals 5. To know whether it's valid or extraneous, you would need to check it. Do you guys feel like you have a better understanding as compared to when you left yesterday about how to go about solving these equations algebraically? Wonderful. The stapled packet that you picked up is your review for the test. When is our test? Friday. Our test is Friday, even if we have a snow day tomorrow. You guys have the review. I will be posting the answer key for that. If we have 2 snow days, I'll bump the test. But if we only have 1 snow day, we're still going to come in and review together on Thursday and then take the test on Friday. So you guys have that review packet. We'll have in-class time to work on it tomorrow if we're here. If we're not, then you need to work on that review packet on your own. And I'll take questions over it on Thursday. One last reminder, your 6-6 homework is due tomorrow. You guys have class time to continue working on that. There are a couple problems where you might want to use the graph, like I showed you how to use Desmos to solve it. You can also use that to check any problems that you do.